Now, before we start this lecture, if you look on your Microsoft Teams account, you will see a multiplication practice. I will go ahead and tell you this. If you are entering college and you can't do your multiplication tables 1 to 10, all of them, or the 100 multiplication paper that I have there for you, ideally in less than a minute, but even if you can even do it in less than 5 minutes, that's okay. Ideally less than a minute though, that's where you need to be with your multiplication. You need to be quick and fast with it. You need to know your multiplication, especially 1 to 10. Ideally 1 to 12. But if you can't do simple multiplication 1 to 10, you're going to have a very, very difficult time doing college mathematics. So I encourage you to pause right now. Go take that multiplication practice. Set you a timer on your phone and see how long it takes you to do it. And then if you can't do it, especially if you can't do it in under 5 minutes, practice, 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 practice until you can do all your multiplication in under 5 minutes. There are many. All you have to do is do 100-question multiplication quiz. Google it. There are many, many, many different ones you can print out and practice on that do it in different orders and everything so that you can spur your brain into memorizing what these multiplication facts are. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 2 times 2 is 4. 2 times 4 is 8. 3 times 3 is 9. 6 times 6 is 36. Anything 1 to 10 you ought to know automatic. 7 times 6 is 42. 8 times 8 is 64. 9 times 9 is 81. Okay, you need to know these. If you don't know these, you will have a calculator, but honestly, if you don't know those right off the bat, you're just going to be so slow in working through problems that it's really going to hang you up in college getting through these problems without basic multiplication skills. Got to have those skills. I can't teach you those skills. Those are something you just have to go out and practice. Get you some flashcards if you got to get flashcards and practice them and practice them and practice them on your own. You have to have that drive to make yourself successful. You can't expect to just watch a video online and get it. That is one thing you hopefully learned in third or fourth grade, and you got it in there. But some people let themselves get rusty on, and they rely too much on a calculator for them. You really need to know those. If you know those, then you're going to be able to work through problems a whole lot faster with a whole lot more confidence. You shouldn't have to take a calculator and try to figure out what 6 times 8 is. You should know that it's 48. Now, let's look at some of these multiplication properties first. First one we're going to look at is the commutative property of multiplication. So x times y is the same thing as y times x. The order does not matter when you multiply. Okay, if you're multiplying two terms, it doesn't matter if you do 2 times 3 or 3 times 2. So here, if I do 2 times 3, that's the same thing as saying 3 times 2. Because 2 times 3 is 6, and 3 times 2 is 6. It's the same thing. That's the commutative property of multiplication. You also have the associative property of multiplication, which kind of just builds on the commutative property a little bit, but it basically also says here that order doesn't matter. If I have x times y times z, that's the same thing as x multiplied times y times z. Okay, the order doesn't matter here, as long as everything is multiplied. Your distributive property here, this one gives people a t-total fit, okay, because distributive property eventually builds into foiling, which, like I said, can give people a fit. The distributive property basically says if I have x multiplied times y plus z, all I have to do is distribute the x to the y and distribute the x to the z. Okay, I have to distribute it to both terms, and then I simply add those two products. So x times y plus z in parentheses is the same thing as x times y times x plus z, or x times z. Okay. Your identity element. Your identity element when it comes to multiplication is 1. Anything times 1 is itself. It provides its own identity. You also have the property of 0. Anything times 0 is 0. Okay? So it doesn't matter if I have 100 times 0. is 0. If I have 1 times 0, it's 0. If I have a negative 3 times 0, it is 0. You also have your negation factor to worry about with multiplication. Okay, if you multiply something by a negative number, or a negative in general, here I'm just multiplying by negative 1, it turns that number negative. So negative 1 times x is just negative x, where negative x plus x gives us a 0. Okay, so if you multiply anything times a negative 1, it gives you the negative factor of that number. If you add the negative factor of that number to that original number, it negates it and all turns it to 0. We also have to remember with negation that negative 1 times negative 1 renders us a positive 1. Okay, and that's a factor with multiplication that a lot of students struggle on and mess up on. Okay, negative times a negative gives us a positive. Okay, all right. The last thing we're going to look at here, factor-wise or property-wise, here is your inverse. Okay, everything has a multiplicative inverse. Okay, except 0. So here I have the multiplicative inverse of x is 1 over x, okay? Because x times 1 over x is just 1. So if you want to find the inverse of something, all you have to do, of just a basic number, is put that number under 1. So the inverse of 3 is 1/3. Because if I do 3 times 1/3, I get 1. So 1/3 is the inverse of 3, and 3 is actually the inverse of 1/3 as well. Let's look at some of our practice problems here. Okay, so I'm going to zoom out so we can see a little better. And let's go through these questions. First one says, which property is used in the following expression? And in this expression, we have 4 times 9 plus 8 equals 36 plus 32. Now, what exactly happened here? We went from some kind of multiplication here to just basically an addition. Hopefully you can see that all we did was distribute the 4 to the 9 and the 4 to the 8, because 4 times 9 gives us 32, and 4 times 4 times 9 gives us 36, and 4 times 8 gives us 32. All that did was exemplify the distributive property. Which property is represented in the following statement? If A equals B, then A over C equals B over C. We saw a similar property of this in addition, right? So, this is just going to be an equality property. If two things are the same thing, then they're going to be equal, regardless of the operation that you do to them, as long as that operation is done to both. Here we just divided by C, but A is equal to B, therefore we have a property of equality going on here. All right, number 3 says, which equation shows the commutative property of multiplication? For the commutative property of multiplication. Okay, so if we look at this, in that first one here, it says 5 times 2 minus 3 times 2 equals 5 minus 3 times 9. That doesn't really look like the commutative property of multiplication. If we look at C, I've got 9 times 3 equals 9 plus 9 plus 9. That's not really the commutative property of multiplication either. If I look at D, I have 8 times 1 equals 8. It's more of like an identity property there. The commutative property is in B here. 7 times 4 equals 4 times 7. Right? Order doesn't matter. That's your commutative property. Which operation will not change the value of any non-zero number? Okay. Which operation will not change the value of any non-zero number? This one should be pretty straightforward. That's our identity property there. Multiplying it by 1 will not change the value of any non-zero number. Okay. Now, let's simplify this expression. Okay. We have 9 times y plus z. Now, this will give us an excellent opportunity to use the distributive property, because I can distribute the 9 to the y and the z. If I distribute the 9 to the y, I get 9y. If I distribute the 9 to the z, I get 9z. So I should be looking for something that looks like this. Looks like answer choice B. Now, if you look at answer choice A, it forgot to distribute the 9 to the z. If you look at answer choice C, it forgot to distribute the 9 to the y. And if you look at answer choice D, I don't know what happened there. It got rid of the plus, none of which are right. That is why answer B is the correct one. If I look at number 6, it says, which of the following does not show the commutative property? Okay. Now, if I'm looking at it, A is showing the commutative property here looks like for addition, something we went over last time. So it does show a commutative property, not necessarily multiplication, but of addition. So let's check the rest of them. If I look at B here, B shows the commutative property of multiplication, so that one's definitely going to hold. If I look at C here, that doesn't even give us a correct statement. X times y minus 4 equals x times y. No, that's not even a correct statement, so I don't even think you can consider that one. If I look at D, this is also a commutative property, but in this case of addition. So this is A is a commutative property of addition, B is a commutative property of multiplication, D is a commutative property of addition again. The only one that's not a commutative property is part C. So that would be our answer choice here. Which equation shows the multiplicative inverse of a number? Okay. Remember, if we want to invert a number, all we have to do is put that number underneath 1. Okay. I think it's pretty obvious what the choice is then. It has to be A. So the multiplicative inverse of A is 1 over A. If I do A times 1 over A, that renders me a 1. I'll look at number 8. It says, which property of multiplication is shown? Okay. It says 5 plus 3 times 7 equals 5 times 7 plus 3 times 7. Now, what did they do here? It looks like they put that 7 to both of those terms. Now, this might look a little different than the distributive property that we've done so far, but it doesn't matter which side the multiplication is done on. We could distribute in both directions here, because 5 plus 3 times 7 is the same thing as 7 times 5 plus 3. That is also a property, right? Refresh yourself on which one. But here we're doing the distributive property. We're distributing the 7 to the 5, and we're distributing the 7 to the 3 here. So this is an example of the distributive property. Okay. Which property is used in the following? Here I have 5 times 8 plus 2 equals 5 times 8 plus 5 times 2. This is also the distributive property here, because all I've done here is distribute the 5 to the 8 and then the 5 to the 2. We're just familiarizing ourselves with the properties. Okay. Obviously, you'll have to solve some of these out as you continue further in math, but if you don't even know the rule, you can't use the rule. It's kind of like sports, right? So anytime you play a sport or a game, if you don't know the rules of the sport or the game, you're never going to be able to win or at least play the game right. Same thing with mathematics. Just follow some basic rules and you'll be able to play the game of mathematics. And especially at this level, as long as you follow the rules, the game of mathematics will let you win. Now you get a little more complicated in mathematics. The rules can get a little dicey and a little more intricate. But here, basic set of rules, if we can follow them, we should be able to work out and find our answers. Now let's look at number 10. Which property is used in the following expression? It says A times B times C equals A times B times C. Okay, here all that's changed is where the parentheses are at. So, this would be, obviously, it's a multiplication property, so we can get rid of this addition stuff here. Is it either the associative or distributive property? This is obviously the associative property, because we've looked at the distributive property. The distributive property of multiplication has something to do with distributing, and it also has an addition in there, so it doesn't even look like that one. Obviously, this is the associative property of multiplication. It doesn't matter how we associate them, because we're multiplying them all the way through anyway. So the order doesn't necessarily matter in which I multiply them, because everything's being multiplied. Let's look at number 11. It says the value of any non-zero number will be changed by, okay, the value of any non-zero number will be changed by, well, let's look at the answer choices it gives. A says multiplying by 0. If I have a non-zero number and I multiply by 0, what happens? Any non-zero number multiplied by 0 changes to 0. Okay, so it does make a change. What happens if I multiply by 1? If I multiply a non-zero number by 1, it doesn't change. Anything by 1 is itself. So it can't be answer choice B. If I add 0 to anything, does that number change? If I add 0 to 3, it stays 3. So a change will not occur there. What happens if I divide by 1? If I divide any number by 1, if I divide 111 by 1, it still stays 111, so it doesn't change. The only thing that makes it change here is multiplying by 0. Okay. Number 12. Which property is represented by the following statement? If A equals B, then A times C equals B times C. If we look at it, A says property of equality for multiplication. B says transitive property of equality. C says symmetric property of equality. And D says reflective property of equality. It's A. It's just a simple property of equality. If one thing is equal to another thing, then they are the same thing. It doesn't matter what we do to them, they'll render the same result. Right? So if A and B are the same thing, and I multiply both times C, it's still going to give me the same thing. Okay? Let's look at an example. So if A is 3, and A is equal to B, that means B also has to be 3, which means that 3 times C is also going to equal 3 times C. And it doesn't even really matter what C is. Let's say C is 5. Obviously, if I substitute that 5 in there, 3 times 5 equals 3 times 5 because 15 equals 15. Right? That equality property holds. Right? That's all that's showing there. Which equation shows the identity property of multiplication? Number 13. Okay, the identity property. The identity property basically says that if you multiply something by this, it gives you the identity of what it is. It basically doesn't change the identity. What's the only thing we can multiply by and get the same number back? 1. Right there. Answer choice A. Let's look at number 14. Number 14 says, which equation shows the zero property of multiplication? Which equation shows the zero property of multiplication? This one should be fairly obvious because only one of them has a 0 in it. The zero equation basically says that anything times 0 is, indeed, right. Number 15. Which property would you use to simplify the following equation? Y plus 9. What is this set up to use? Hopefully, distributive property is over there screaming out, use me. Okay, anytime we see a number multiplied by something in parentheses, hopefully we're thinking distributive property here. Okay, because if I were to use the distributive property here, I'd get 7 times y gives me 7y, and 7 times 9 gives me, this is where those multiplication facts kick in, right? 7 times 9 gives me 63. Gotta know it. Don't need to be able to type it on your calculator, just need to be able to, boom, write it down on a sheet of paper. So this last one here. Which property is used in the following expression? Okay, so here I have 2 times 7 times 5 equals 7 times 5 times 2. Okay, the first one, the 2 and the 7 are in parentheses, and the last one, the 5 and the 2 are in parentheses. Okay, the association is what changes, but there's still an equality there because it doesn't matter in which the order I multiply, which leads you to know that it's the associative property. Now, all of these properties are important. Here's something I'm just going to straight out tell you. These properties are what I just said. But, for the most part, it's just like a rule in a game or a rule in a sport. The rules are very important. Now, when I go to play football, baseball, soccer, whatever it might be, the referee's not going to ask me to sit down and write the rule book out. What the referee's going to ask me to do is play the game fairly to get a fair and correct outcome, right? He's not going to expect me to write all the rules of the rule book out. He's going to want me to know them, but not necessarily cite them verbatim. Same thing here in mathematics. We expect you to know what the rules are. We don't expect you to necessarily, at least I don't, expect you to write every single rule verbatim. But when you see it, you should know how to approach it and use the rule to your advantage to help solve something. You should also be able to tell when a rule is being used incorrectly. Because when you're playing a game and your opponent breaks a rule, you want to be able to call them out on it and say, hey, you have broken a rule and done this wrong, right? Same thing here. That's all we're doing. It's just a set of rules we're trying to follow to get to a winning outcome. In our case with math, the winning outcome is just the answer, right? So we follow a set of rules to get to the correct answer and win, just like you would in sports. If you don't follow the correct path, you're going to wind up losing because you'll get the wrong answer. Okay? So think about it that way. Don't think about it as this weird stuff out here that's just all over the place. It's a very set group of rules that if we can follow, we're going to win and get to the correct outcome every time. Okay? And now, it's just like sports. Every now and then somebody will break a rule and they'll still get to the correct outcome. It happens, right? But a lot of times when you break a rule and you do something wrong, you don't get the correct outcome. So learn the rules, know what the rules are, familiarize yourself with the rules, but know how to use the rules to your advantage to get the right outcome, and know how to identify when a rule has been used wrong so that you can correct it and still find a way to the correct outcome, or at least call out that something's been done incorrectly, right? So I'm using the distributive property wrong, and I'm only distributing to the first term and not to both terms, then hey, I'm using the rule incorrectly. I'm going to get the wrong answer. I'm going to lose. Nobody likes losing. Use the rules correctly. Know the rules so that when the rules aren't being used correctly, it looks like a big red flag. Or just like a big yellow flag in football, right? When the referee throws it because somebody went off sides and did something wrong. Same thing here. We're reviewing these basic rules. We're going to put these rules into action. And then we're going to try to solve anything we need to solve and work towards anything we need to work towards so that at the end we can get the answer and win. Okay? Small victories lead to big victories. Each problem is basically a game. If I can get all my problems right, I can definitely make 100 and win at the end of the day. Just trying to get you there. But the first thing you got to do is you got to put in the practice, just like with sports. So if you have not yet, I know it seems very simple, but sometimes you would be surprised if you sit down and actually make yourself practice and try. Please go and try the multiplication little quiz that I put in here for you. It doesn't say quiz, it just says multiplication practice. Print it out, or you could do it on your computer, right on your computer. But seriously, take your phone, and you don't have to put a timer on where it beeps and goes off at 1 minute, but put a timer on to see how long it does take you to do it, and then check yourself and make sure you got everything correct. Don't use a calculator. Do it all from your brain power. And practice as many times as you need to practice to try to make sure you can memorize those multiplication facts. Because, like I said, if you can't do some basic multiplication when you're going to college, you're really going to struggle. Got to build those foundation blocks to get you where you need to go. Got to put in the work now so that later it'll be a lot easier and you'll have a lot better chance at success. If you have any questions, please don't hesitate to reach out. We'll continue on with our lectures next time. And